Hi everyone, my name is Matthew Farah and this is a video illustrating the science behind why marathon and long distance runners are able to run 5,000, 10,000 meter and 26-mile marathons. In my previous video on Usain Bolt, I covered the muscle type differences between sprinters and long distance runners. However, in this video, there's going to be a focus on a runner's ability to utilize oxygen. Also, before we start, subscribe and comment down below what other sports stars and athletes you would like us to cover next. As covered briefly in our previous video, marathon runners tend to have a very lean body adapted for long distances. If we look at the heights and weights of the last 5 London Marathon winners, we can see that being a lower weight and height is beneficial for this event, reducing the impact on joints when running, and also meaning less blood and less oxygen is actually required to fuel heavy muscle types as seen in sprinters such as Justin Gatlin. The impact on joints can be seen with patellofemoral pain syndrome, also known as runner's knee or PFPS. This is the most common injury reported by marathon runners. Additionally, shin pain or shin splints are also very common if you run without the right technique. The biggest factor to why athletes can run extremely long distances is an adaptation to a compound called hemoglobin found in red blood cells. Hemoglobin is a structure which binds to oxygen in the lungs and is then transported to muscles. In a normal person, red blood cells are wide, biconcave disc-shaped cells, giving them the best adaptation to carry oxygen in the blood. Hemoglobin combines to 4 molecules of oxygen in each red blood cell, and itself is made up of 4 subunits, 2 alpha and 2 beta. The affinity for hemoglobin to bind with oxygen is demonstrated in an oxygen hemoglobin dissociation chart. When exercising, the line will shift right as oxygen is required by the athlete's muscles, meaning the bonding strength has to be reduced in order to release oxygen from the heme subunits. This can be developed when training at high altitude in the mountains of countries such as Ethiopia and Kenya. Training at high altitude is harder due to the lower atmospheric oxygen concentrations. However, this is extremely beneficial as marathon runners develop a compound called BPG. This causes the curve to shift right also, and BPG binds the deoxygenated beta units in hemoglobin and therefore decreases their affinity to bind to oxygen, meaning that oxygen is more readily released to respiring muscle cells, reducing the buildup of CO2 and production of lactic acid, causing cramp. This benefits athletes as it means they can increase the amount of oxygen in their blood. This factor is seen by looking at the P50 value, which is a measure of the partial pressure of oxygen in the blood at which hemoglobin is 50% saturated. A normal person's P50 typically is around 26.6 mm per mercury. An increased P50 indicates a rightward shift of the standard curve, which means that larger partial pressures are necessary to maintain 50% oxygen saturation, ultimately meaning that at lower oxygen concentrations, for example when running a race, marathon runners, red blood cells can still readily release oxygen to their muscles. Another factor to why marathon runners are able to run for so long is their diet. 48 hours before a race, runners are only eating small meals to prevent feeling of bloatedness and packing their diet with electrolytes, energy bars, and long-lasting carbohydrates. This will enable athletes to have a high fuel reserve of energy necessary to complete the tremendous task of finishing a marathon. Thanks for watching everyone. Let me know if you would like to produce a video on what actually happens to a marathon runner's body during a race. Also, make sure to subscribe if you liked this style of content on the scientific and medical side of sports. Share the content with your friends and like the video before you leave. Finally, comment down below what other athletes you would like me to cover in the future. And once again, my name is Matthew Farah and thank you for watching.